Yes. Is my voice clear?
Yes, sir.
Okay. So let's talk about this. Gravitational force is basically that topic what we have to discuss with, or that topic we have to make all these areas of gravity and all that stuff. So simply speaking, that in gravitational field, we will be talking about gravitational forces, gravitational law, field strength, gravitational potential, and gravitational potential energy. This is one of the parts, right? So this is one of the part we have to discuss. Second part is basically these planetary motion, Kepler's law, kinetic energy, escape velocity, satellites, and binary stars. So these are two main parts of your uh, gravitation. We will discuss about them all. So this first part may not have that much impact of circular motion, but this next part, it has a lot of impact of circular motion. So talking about the laws of gravity. Uh, yeah, when we talk about laws of gravity, law of gravity means very simple, that this is, although we learn the law, uh, which is to be recalled, because there is no amendment we can make, and law is law. So if you ask me, sir, why the forces are being produced by these masses, so I will not have any answer for that, because till this point we are just expecting that graviton is that type of particle which is transforming that force, or which is basically responsible for these gravitational forces. So that is why graviton.
Isn't it like hypothetical?
Yeah, this is hypothetical. We did not have it yet. We are not able to capture that. It has that much rapid decay that we are unable to capture that. Okay.
Okay.
Okay. So uh, that is why we will simply say that we will talk about the law outcomes of this. Uh, that means that if we have this two masses M1 and M2, and these two masses are placed closer to each other at a separation r from each other, then they exert a force on each other, and that force is the force of attraction, not the repulsion. There are several properties of this force. I will talk about these properties one by one, inshallah. So the law states that if there are two masses M1 and M2 separated by a distance separation r between their centers, then the force of attraction or the repulsion will be, sorry, force of attraction, not repulsion, force of attraction will be directly proportional to the product of their masses and inversely proportional to the square of separation between their centers. This is the simplest statement of this law. Although this is the statement, but there are so many concepts, so many calculations, and all that stuff which is asked to you from this single statement. So let me explain it to you. This is asked for 2 marks in your CIs, right? One of them, that the statement of the Newton's law of gravity is that the forces between the 2 point masses. This is very important. You have to add this in your notes, that the force between 2 point masses. We are talking about the point mass. So I will talk about that what a point mass is. But first of all, I will let you know that the force between 2 point masses is directly proportional to the product of their masses and inversely proportional to the separation square of separation between their centers. Okay. So that is why we simply say that, oh, yes, that means that if we have two objects and those two objects are uh, having the masses M1 and M2, and they are separated by r from their between their centers, then those two objects will have the force F between them, That force F is directly proportional to M1, M2, and inversely proportional to the square of R, square of separation between their centers. Mathematically, it is. And then we have a constant involved here. That constant is called universal gravitational constant. G is the universal gravitational constant, and its value is 6.673 into 10 is power minus 11. This is very smaller value, very, very tiny value. That is why we do not feel the force when we are having two bodies interacting with each other, right? Very small bodies. Now, I will talk about that. This is equal to F is equal to minus G m1 m2 divided by r square, where the negative sign shows the force of attraction, but this is not the vector nature. Okay, this is basically the attractive nature of this. So that is why if you just simply add this, add page, tags, page. There is no page in this. Okay, I will talk about that. Okay, so this is basically the important thing about the forces. Now, the graph of the force is simply that because it follows inverse square law. So I can simply say that this F is inversely proportional to square of R. That is inversely proportional to square of R. And if you simply state that the graph will give you the force and R. So force will be maximum at one point, and actually it would be an asymptote if you just ask me. But simply here I have just stated that force is maximum at when the R is zero. Now there is a variation. There are some points I wanted to add here, but because in these notes there is no space to add, so I will add a page here. Is there any option to add the page here? Okay, no, it is some other file, I think so. Is it? Okay, no. That is not good. Okay, let me write some things on the other notes on the other side so that it will be helpful for you. I will share this file to you. Now, do you see that file? The other side.
Yes.
Okay. Here, basically, I'm just below this yellow line because above this yellow line there was quantum mechanics, and below this yellow line there is gravitation. So that is a blend. So actually, the I want to write the of properties of gravitational force properties. So first of all, if you want to know that this F is basically F is attractive. This is the most important property of this force, that it is attractive, and that is given to it by a negative sign. And in negative sign is the symbol or the identification that this force is attractive. Okay.
Okay.
Secondly, it follows inverse square law. Third, it works in pair. This is the most important thing. It works in pair. How? That it is equal and opposite for both the bodies. Yani I'm explaining this that it is equal and opposite to both the bodies. Okay, both the bodies. Right.
Okay.
But the problem is its impact is on the smaller body. What is its impact? Its impact is at smaller mass. Yani, I will explain that smaller mass. That means that if I am standing on the earth, right, then this mass is very big, right? Now, that mass will, or that earth will exert a force on me. Let's say my mass is very small. I will simply say that the mass of the earth is 6.0 into 10 raised power 24 kg. This is the mass of the earth, and the mass of a person is almost 80 kg. Okay, are you getting my point? Okay,
Yes.
both are separated by a distance equal to the radius of the earth, and which is equal to 6.4 into 10 raised power 6 meters. Okay, you got the point. Now calculate the force of attraction between these two. Can you please calculate it for me? F is equals to G M, mass of earth, mass of the person, divided by radius of the earth whole square. Do you have calculator?
What was G?
Yeah, 6.673 into 10 raised power minus 11 into mass of the earth is 6.0 into 10 raised power 24 into 80 upon the radius of the earth is how much? 6.4. It is mentioned here into 10 raised power 6 whole square. Yes, please.
Oh, approximately 780.
780
80.
Newton. Almost. Right.
Uh, mm,
Now,
we could just,
the,
yeah, yeah, 8 times 9.81, yeah, same thing.
exactly. Right. So, if I say that weight of my body is my mass into value of G on this planet, and value of G on this planet is 9.8. So my weight is equals to 80 kg into 9.81. So what are you getting here? Almost the same, na?
Yes.
So that is why your previous concept was basically the concept of weight, and that concept is now converted. That weight is what weight is actually the force of attraction of the earth. Force of attraction of earth. ठीक है?
Yes, sir.
Okay. So I can simply say that in this situation, if I move on, I will say that this force, yani my weight is the force of gravity on my body. Is it? Force of gravity on my body. The gravity of me and earth. Right? Weight is basically that. So weight was the force by which earth was attracting me towards its center. Was it its definition or not?
Yes.
Yes. So that we call that weight is the gravitational force, gravitational force by which Earth, and in this case, all the planets attract the objects towards their centers. Is it?
Yes.
Now, let's talk about that. Actually, my point was this. I am explaining this point that the impact of that force is on the smaller body. This is really, really interesting point and crucial point. So I wanted to explain that. That means that my yani impact mean acceleration, right? Impact mean acceleration. So what will be the mm, acceleration of Earth and what will be the acceleration of man? That is that will be force divided by mass, and the acceleration of the Earth, this capital E, that is the force divided by its mass. So can you calculate this, please? The force was almost 780 and my mass was almost 80. So I can say it is almost 9.81 meters per second square. And if I just consider this, that force was 780 Newton and the mass of Earth is 6.0 into 10 is power 24. So is it almost 000? Is it?
Yes.
So that is why Earth does not experience any pull. You got this point?
Yes.
That is what I wanted to tell you. That basically, once we are talking about the Earth or the impact of the bodies, we mean that the acceleration will be affecting the smaller body, not the larger one. Okay?
Yes.
So, any confusion or you want to ask me any question?
No, sir.
Not at all?
No.
Okay. So, that is why you must consider that this works in action and reaction, right? This works in action and reaction. Now, moving onwards. So, basically, these points are really important for you, and these points means that once we are talking about the gravitational force, we must have a clear concept of the gravitational force. So, on those notes, I have not yet explained the gravitational force in that much detail because that was a short and brief description. Now, if I say that the surface of the planet is something like this, and there is a force over here, then for example, this is distance r, this is distance 2r, this is distance 3r, this is distance 4r, and so on. So if at r the force is F, right, then at 2r it would be 1/4, 1/4. Remember this thing. This is F, this is, let's say, F by 2, and this is actually F by 4. So it would be reduced to 1/4 this way and this way and this way. So it will never be touching zero until unless the point is very extremely infinite. But there is one more problem in this concept. That is the value of g. It is 6.6 73 into 10 raised power minus 19 minus 20 minus 11 cool joules, sorry, Newton meter square per coulomb Newton meter square per kg square. It matters a lot. Why? For example, if you have two bodies and these two bodies are in front of each other, and these two bodies have the mass of, let's say, 1000 kg each. 1000 kg is 1 ton, na? There are two spheres of 1000 kg, and they are placed in front of each other. Yani the separation between their centers is very small, even. It is equal to 1 meter. Yani the separation is 1 meter, right? 1 meter separation. Then how much force will they exert on each other? 6.673 into 10 raised power minus 11 into 10 power 6. 1000 is basically 1000 square divided by 1. So it is so small, 6.67 into 10 raised power minus 11 into 1.0 into 10 raised power 6. So that means that 6.67 into 10 raised power minus 5 Newton is almost again 0.0000007 Newton, which is almost zero. Am I right? So it is 1 ton object, right? Do you believe this thing? That why this 1 ton object is not able to attract the other object? Yani, they are attracting that. Why we are not able to experience their movement, experience their acceleration or impact? This is the concept, the value of G. It is very, very, very small. Okay, is
Yes.
it clear to you?
Yes, sir.
Okay, so uh, then we will be talking about the variation of, yes, one more thing. I will be talking about point force in today's lecture, and then we will be talking about the rest, all of the aspect in the next lecture. Point mass. What does it mean by point mass? Yes.
Like, point is just point. It's just a point particle.
Yes. Actually, point mass is uh, that mass which is uh, very small comparatively. You will say that, okay, sir, what the nonsense that is? Earth is a point mass. Earth is small. No, actually, that is a comparison. Point mass, the mass whose radius is very small as compared to that of the separation from the other mass, right? The mass with, yani the masses, I can say, masses with a very small radius or size as compared to the separation between them. Okay, separation
Okay.
between them. Yani, if I say that this is Earth, right, and this is Moon, although they are not the very small objects, its mass is 6.0 into 10 raised power 24. Its mass is 7.2 into 10 raised power 22. But their radius are very small as compared to that of their separation, right? Their separation is very big, but their size are where their radii are very small. So this is basically the concept of point mass. You got this point? So if the radius is very, very small, as compared to that of separation between the planet. Then object is said to be point mass. Okay, ji? Is this clear to you?
Yes, sir.
Yes. So in this way, we have different, you know, aspects. We have different concepts of this. For example, this there is a question of the torsion balance, that there is a sphere and that sphere is pivoted from here, right? And for example, once it is brought closer to another sphere or any other mass, it has changed its position by this angle beta, right? And its mass is something, yeah, this is its position number one, and this is its position number two, although it must be in dotted line. Okay.
Yes.
uh, yes, so you can consider that if there is a mass like this big mass here, that will attract this point. So actually the questions can be asked to you in different formats. The force of attraction is used here to produce this torque. Torque is given to you in that question, right? Torque is given to you. I think that is in certain value, and yes, I hope that that is in certain value. The torque is given to you. That is 0.65 times beta or something like that. I will figure out that question and I will solve that question with you right here in the class. Okay. And then you can calculate the force. For example, torque is given, then you can calculate the force very easily. Okay.
Yes, sir.
Yep. So that's it for today, inshallah. We will discuss about the rest of the concept of the force in the next class, inshallah. Okay.
Okay, sir.
Okay. See you
Yes, sir. Allah Hafiz.
then.